All right, so first of all, ODP for today is posted. I'll post another one tonight for tomorrow. So today's ODP is doing file processing, similar to what you did a couple of ODPs ago. And the main setup is you have a file and it contains either integers or gibberish. And you're supposed to read this file from beginning to end, and if it contains an integer, add that to a running sum. If you get to a line and it doesn't begin with an integer, it's hello or haha, just ignore that line, go on to the next line. Okay, and there's a sample file in there that shows you a sample file and what you should return in that case. And the difference from the previous thing where you were just reading an integer and returning that is you need to loop, right? And fgets, which is the best way to read from a file. So give it a character array, length, and then some sort of input stream, standard in if you're reading from standard in, but if you open a file, it returns a file pointer, use that as your third argument. This will return null when you get to the end of the file. So you can put all of this inside a while loop if you like. So while null is not returned by fgets, and then in here you can do your scanf. On buffer, look for a %d in the beginning. If scanf returns a 1, you got an integer. Take the thing that you scanned, add it to a running sum. If it returns a 0, don't add anything to the running sum, right? Just go back to the top of the loop, and then at the end, return whatever the sum was.
So how fgets works, it gets the string
Up to and including a new line or 119 characters, whichever comes first. And I won't give you any long lines, so if you do like 120, that's fine. And then scanf you can use as many times as you want, as many ways as you like. All right, Wednesday, beginning of this class, I'm going to have a former student come in. He'd like to talk to the class for about 5 to 10 minutes. He's gotten involved in a nonprofit startup that's apparently really, really doing well. Their focus is teaching coding to kids, and they desperately need teachers. So I don't know any of the details beyond that, but I told him he could come in at the end of the 11 o'clock class and then stick around for the first few minutes of the 12 o'clock class here. So that'll be on Wednesday. His name is Chris Height. He was here, finished the program last year or the year before, I don't remember. So he'll talk about that for a few minutes, and I don't know, summer work, internship possibility, I have no idea. But could be something cool to look into. All right, PA4 is graded, and comments and grades are in Canvas. PA4 was really good, okay? Deletion and breadth-first traversal are big, complex beasts, right? And we kind of expect some issues with that, so that's not startling. But the basic mechanics, creating a tree, inserting things into a tree, traversal, searching, for the most part, no issues with that, right? Everybody seemed to be doing the right thing. There was a fair amount of nickel and diming, actually. People were doing traversals, but they forget one of the 3 depth-first traversals. Or some people, instead of doing node left, right, they did something like right, left, node, which we've never really talked about. Just little things like that. The annoying comma at the end of the traversal output, right, which I eventually felt really bad for taking off a point for, because a lot of people had like hundreds, but then they had a comma on the end, and I had to give them a 99. But other people had worked, in some cases, very hard to get rid of that comma, so I needed to recognize that. So it was a point if you had a comma on the end. It seems annoying, but so little things like that, right? But the general operation of you know, allocating memory and linking together nodes and working through these structures, that's working for most people, and that's great, because we're going to use trees in 223. We're going to be, instead of just building trees, we're going to be using them to do other things. So that's good that that people are getting comfortable with that. And it's going to come up on the final, right, tree-like things, I may not, well, I'm definitely not going to say, you know, write a function for deleting a node from a tree, okay? Because you've already done that, right? Or you've seen code for it or something. But the kinds of things that we've had to do to traverse trees, to insert stuff like that, you want to be familiar with that and comfortable with that because we'll be doing similar things on the test. All right. So this brings us to the talk. And I hate giving the talk, but it's time to give the talk again. We did this in 224, but we need a refresher on this. So the talk is about plagiarism and about turning in your own work and working with other people and being really clear where the divide is between working with other people or finding, you know, information online versus what would be considered plagiarism. And I know that nobody in this class or in the other section is trying to cheat on their assignments, right? The assignments aren't worth that much. And the cases where I saw questionable things, I know the people involved have been working on this stuff really hard, right? I've seen people working on it. We've had, you know, one-on-ones talking about questions, things like that. So I'm not concerned that people are coming at this ethically from a bad place. Okay, my concern is that there's a really big gray area between using other sources to help understand the material and plagiarism. Okay, and for this course, with this class, right, I tend to focus on this side where people are trying to do their work. But as you move on from Clark, as you go to a four-year university, if you go on to more schooling, if you're writing papers, if you're doing things for job interviews and so on, that line can get really, really fine, and it can move all over the place. So what is plagiarism? There's this thing called the 5-word rule. When you're writing papers, it says if you have 5 words in a row that are the same 5 words in that order from some other source, you've got to put it in quotation marks and put a citation. So-and-so said, quote, blah, 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 close quote, and a reference to who said that. Otherwise, it's considered plagiarism. There's a thing called the 3-word rule, right? A good rule of thumb to avoiding plagiarism is that whenever you use 3 or more words in a row from a source, it's always best to put those words in quotation marks. 3 words. Right? And if there are 3 common words, like to begin with, right, there's definitely a paper somewhere out there with those 3 words in them, right? And you don't want to cite every paper that has 3 words like that in a row. But if they're words that are somewhat unusual, right, this can be an issue. And so here, I don't know whose standard, there's standard punishments for plagiarism. First offense, 0 or F. On the assignment, second offense, F for the course, third offense, dismissal from school. Okay, that's fairly generous. There are schools that will kick you out on the first offense. So I have a friend, when she was an undergrad, she was taking a biology course, and she wrote a paper, and she had 7 words that were the same as another paper that the teacher found. And it was something like, therefore, the total concentration continues to decrease. It was something like that, right? A sentence that is not the kind of sentence you would like rip off from another paper deliberately. But the teacher had a clash with his student. There was a personality issue. And that may have fed into this, because after the student submitted the paper, she got a notice a few days later saying that she had to appear before the honor board. And that's a really horrible feeling, right? That's not something you can ignore. That's something where you're going to go into a room with a bunch of faculty, right? People with power over you, and you're going to be accused by one of your teachers of cheating, plagiarizing, and you're going to try to defend yourself. And she had her materials that she used when she wrote this paper and had done the research for this. And she had different drafts of this and so on and so forth. And she was well known at the school. So she had character witnesses. And in the end, they decided that this was an innocent mistake, that it should have been referenced, but it was not intentional plagiarism, and she was allowed to continue with her education. But if not for all of that, she would have been out. And that's it, no bachelor's degree. Really hard time getting into another school after that, really hard to get a job after that without a degree. So it can really change your life. So when I was an undergrad, I got to experience this from the other side as well. It was a course on programming in Pascal, and one of our assignments was to write something like the word index program that would take a Pascal program, the source code, and it would identify variables, functions, all the different identifiers in there, tell you where they were declared, where they were used, how many times they appeared, and print out this nice alphabetized index, right? So it was a way to analyze source code. And it was a big, hairy assignment. So I got it done really quickly. I did nothing but write code back then. So I got it done quickly. We had a week to do it. The week came, I turned it in, nobody else had their assignment done. Teacher said, okay, take another week. So that was annoying. But next week, everybody else turned their assignment in. The following week, we got our assignments back, and I had a 20 on it, 20 out of 100. And no comment, just 20 out of 100. So talked to the teacher, and I said, how come I got a 20 out of 100 on this? He's like, I gave you 20 points for typing it in yourself. So I talked to him about this, and he said, this looks a lot like some code that I've seen elsewhere, right? That was it. But we started talking, and here's what he said, and my friends teased me about this endlessly once it became funny. So this is what I looked like at the time. I had good 80s hair going, right? And this teacher, I think he worked for the CIA, so he was very, like, you know, short hair, straight-laced. And I was talking to him about this, and he finally said, here's the thing. I look at this code, and I look at you, I don't see the connection, right? And that was it. Because I had long hair, this teacher accused, and I wrote good code, this teacher accused me of plagiarism, right? So hopefully that never happens to anybody here. Hopefully we're a little more enlightened than that. But it doesn't take much, okay? So when I'm looking at, and that worked out fine because I knew all the other teachers and faculty in the department, and I was able to explain all my code to him and all the weird things I had done in there to make it work, and he decided he had made a mistake. So here's what happens when I'm grading these programming assignments. Most of you have had you for 224 and 222, and coding becomes kind of like a signature, right? We all develop our own styles of coding. The way that we indent, the way that we pick variable names, the way we write if statements, things like this, becomes very personalized. And I'm getting to know people's style. And sometimes when I'm looking at code, things jump out. You see something that's just different from what you've seen in the past. And it could be something like, you know, we write something like the total sum equals blah, blah, blah. But some people write the underscore total underscore sum, right? Snake case. And some people would write camel case, where you uppercase the first letter of each word, makes it easier to read, right? And when somebody's whole program is like this, but there's one section of code that has all of this in there, right? It makes me wonder. Or if there's terminology that we've never used in class and that I've never heard from a discussion with a student, and all of a sudden this terminology is in there. Or a different commenting style or things like that. So I'm not looking for things like this, but sometimes they kind of jump out. And when they do, I'll usually grab a line of code and I'll throw it into the search bar on Google. And more often than I wish, it brings up a page and there's the student's code. Now sometimes it's the same statements and the comments have been changed. Sometimes the variables have been renamed, but it's the exact same structure. Sometimes it's verbatim, Okay, no one in this class, but in other quarters I've had this where character for character, same comments, right? Everything's exactly the same, and it's pretty clear. I'm really, really adverse, though, to telling somebody, you know, this is not your work, you copied this, right? Partially because I've been on that side, that other side of things. But here's what can happen. You're trying to figure out how to implement a queue, right? And it's just not working, and you want to find some ideas. So you look online and you're looking for algorithms for queues, possibly for queues involved with binary search trees, and you come to geeksforgeeks.org, right? Lots of good sample code. You can look at that code and analyze it and figure out what the algorithm is for implementing a queue and compare it to what you're doing and say, oh, I forgot to adjust the tail pointer, right? And then you go back to your code and you make a change, you adjust the tail pointer. Okay, that's okay. That's making use of other resources. That's really no different from coming to me or from looking at what we've done, you know, in the videos and so on. But sometimes you look at that code and you stare at it for a while and then you say, oh, I was doing mine completely wrong, and you start from scratch. But even though you think you're writing your code, you're really kind of writing what you just looked at. And the effect is that it comes out and it looks like 7 consecutive words or 5 consecutive words or 3 consecutive words, right? And that's what you want to be really careful to avoid, because other schools will really nail you for it, okay? So, so this is the Gilligan's Island thing, right? If you look at code, you're supposed to go away and watch 3 hours of Gilligan Island reruns to sort of flush your brain out so that you don't inadvertently start regurgitating the code that you just saw, right? So look at code, make notes about the algorithm, right? Because we teach you algorithms here. We teach you how do you do a queue, how do you delete from a tree, right? That's stuff that you're supposed to be learning in this course. And if you look at code for tree deletion to understand the algorithm, right, make yourself notes about the algorithm, and then watch Gilligan's Island reruns, and then sit down to an editor and start writing the code using your notes on what the algorithm is, what the function is supposed to do, but make sure it's your code coming out. Does that make sense? It's a fuzzy area, to be sure. But if there's an opportunity to err, right, err on the side of caution. And modifying code, right, changing variable names or spacing or things like that won't work. I don't do this, but there are tons of tools out there that you can take all the assignments that students submit and feed it into this program, and it'll compare each program against every other program and look for similarities. And it'll ignore comments, spacing, indenting, coding styles, variable names, things like that, and it'll look for structure, right, and tell you degree of similarity between programs. And other schools use that kind of thing. I don't do that, right, because I'm confident that people here aren't trying to, you know, turn in work that's not their own or get credit for somebody else's work as theirs. It's the inadvertent stuff that's harder to avoid in some ways. So just keep that in mind and be really cautious around that. And geeksforgeeks.org actually has some errors on it. So they coded the height function wrong. So, all right. So enough of that. Let's look at PA4. This is done uploading. All right, so let me show you my version of PA4. It's not the only or the best, it's just a solution. It's a version. So one include file, right, which defines my structures and then prototypes all my functions. So tree node, no surprises there. So a node pointer for the left and right, and then integer data. The order of this doesn't matter because I'm using this everywhere in my program, right? Now, if I was trying to link this with somebody else's code and I tried to use their balance function on my tree and I had a different order in my structure, right, that can cause havoc. But within your own code, as long as you're consistent, the order doesn't really matter. So I defined a struct type node uppercase N, which is a struct node pointer. And then my Q code was straight from PA3. Okay, I had my own version of PA3's Q code. The only difference was my data, instead of being an integer, is a struct node star. Okay, and I had to change that anywhere that I passed an argument to one of my Q routines or got a return value. But other than that, the Q routines were unchanged. So the usual next and tail pointer. And then just a mass of function prototypes, which I put in just for you because I want you to do them too. All right, so tree assignment, NJM. Put your name in your code, okay? Don't just use your initials. Put your whole name in. Put in the class, the date, the assignment number, and a description in your own words of what the assignment does. Don't be afraid to be verbose here, okay? A lot of people just said, you know, here's my name, binary search trees. Okay, I can't argue with that, but 6 months from now, you're at WSU, and you've got an assignment with binary search trees, and you want to go back and look at your code, because you already did this at Clark, right? If you've commented your code well, it's going to be more useful to you. If your code has no comments in it, and it's all justified on the left column, right, you're going to get a headache trying to figure out what you did. You're going to have to learn it all again and do it again from scratch. That's not necessarily bad, but it's a nice resource to be able to go back to your old code. All right, so I got lazy on my traversal code, right? Fundamental rule of computer science, be lazy. So I wrote one set of traversal code, and I passed it an argument to say what order I want to traverse in. And I set up some symbols for pre, post, and in order, instead of just passing magic numbers 1, 2, and 3. So that's just a nicety nice thing. Main program, so my tree is called root, and I initialize it to be null. We don't have a sentinel node in tree, so you don't need something like an init tree routine. You could have it, but all it's really got to do is just set the root to null. Okay, that's an empty tree, that's an empty list, that's an empty anything without sentinel. All right, so what do? Print out a welcome message, right? You feel welcome now. And then read a line of input. So fgets, right? You'll see this again and again and again. So read from standard in up to 120 characters into buffer. And if it returns null, I'm going to kick out of my while loop. So if I'm reading from a file and I hit end of file, that'll kick me out. That's just kind of a habit. And at the end of your loop, I call release, which releases all the memory from my tree, and then I just return. So that really ends the program. All right, so I've read in one line of input. All right, we have a variety of commands that we might be issuing. So we might just say something like 25, which means insert 25 into the tree. We might say X, which means show me stuff about the tree. We might say search for 25, which searches for a node, and so on. Or we might say something totally meaningless, like haha. Since you've done an fgets, whatever the person typed, that's sitting in a string, a character buffer, and it's not going anywhere. So you can parse that as many different ways as you like. You can look at individual characters, you can run it through scanf, you can check its length, you can do all kinds of things to it, okay? And it's not going to change until you say, typically do another fgets. So we're free to parse this as many times and as many ways as we like. This is the easiest case to determine, because if you use scanf and you just search for a %d, if that returns 1, you know there's an integer in the beginning of the line. If it returns something other than 1, there's not an integer in the beginning of the line. So this is pretty easy to detect. Scan your buffer with a %d, see if it returned 1. And if it did, then whatever you put as an argument, that'll be the value of the number. Things like this, you can scanf with a %C and see if it returns an X, or you could say, just look at character 0 and see if it's equal to an X, either way. Things like this, you want to scan with either a %C followed by a %D, and then see if the %C is an S, and then if scanf return 2. Or you could just scan with an S space %D and see if it returns a 1. And if it does, then you know that there was an S followed by an integer. And again, whatever variable you use has the value of that integer. So you got a lot of options, right? The important thing is you don't have to panic. If you're using scanf, you got to panic. You got to worry about how you're parsing this thing, because scanf absorbs input from standard in. And once it parses something, it's gone, right? So you can't go back and rescan it. So using fgets lets you pull this into a string and then casually do whatever you want with the string. All right, so first thing that we check for is see if it's an integer. Okay, so scan it with a %D, see if that returns 1. If it does, let's search for that number in our tree. So search takes the root of a tree and a number, and if it returns something not null, it means it found that number in the tree. So if I'm trying to insert something that's in the tree, I print an error message and say error, that number's already in the tree. Otherwise, it's not in the tree, so call insert, pass the root of the tree and the number, take what it returns, set root equal to that. So that's the whole section for inputting a new number into the tree. Otherwise, we don't have a number. We've got either a command or a command followed by a number or gibberish. So this part is what we do when we don't have something that just begins with a number. So I used a switch. Switch is just a bunch of if statements, but it lets you structure it a little differently. So I switch on the first character of the command, right? And we have these single character commands anyway. So if the first character is X, I call a routine called examine, pass it the root of the tree. That's going to do all the printing out that X is supposed to do. Okay? None of that in my main program. I don't have to look at it, I don't have to think about it. I just say call examine. If there's a question mark, I'm going to call a routine called usage. That tells the user what their legal commands are. Again, I don't put that in here. I don't want to look at it. Just give a usage message and go on. All right, if the first character is an S, then we do one of the following things. Parse your input buffer and make sure that S is followed by a number. If it's not, I can print a message, S should be followed by a number to search for, and I'm done. Otherwise, they said search space and some number, which is num, so I call the search routine. Save the result in temp. I didn't really need to do that. And if that's not null, then I say I found that number. If it is null, then I can say the number is not in the tree. So that's search. Delete is similar. So make sure it's delete followed by a number. If it's not, print a message, D should be followed by a number to delete. Otherwise, search for it. If search returns null, can't delete that number, it's not in the tree. Otherwise, call delete, take the value it returns, set the root equal to that. All right, Q, print out a message, say freeing memory, call the release method, and then just return. And anything else, I just print a message that says enter a question mark for help. And that's the whole input loop. So that just keeps running until something causes you to exit the loop, either a Q or you hit the end of the file, in which case we go ahead and exit out. Print out a prompt, go back to the top of the input loop. And then if you come out of that, free the memory and exit. So that's main, okay? And there's lots of ways you could do that, but they all kind of feel the same. Yeah?
And you're using an assignment statement in conditional, so does that just evaluate to?
This? Yeah, so this sets temp equal to the result of search, and that's parenthesized right here. And then this says if null is not equal to the result of search or temp. That's just a shortcut, and I didn't have to do that. I must have been doing something with temp at some point. but not anymore. And that's the same thing as, oh no, we're not doing that here, never mind. All right, so that's input loop. So deletion, all right, so deletion is the big bugaboo, right? And we had a very specific algorithm for deleting. So if the root's null, we just return null. That should never happen. If you know that the node's in your tree, root should never be null. But if you try to delete something from an empty tree, just return the empty tree, don't make any change to it. Do we want to print a message here saying tree is empty, can't delete? Would that be helpful? Probably not. Right? We don't know what this person's doing with this. Maybe they're trying to free memory or something. And at the end of your program, you're going to get 20 messages saying can't delete from an empty tree or something like that, right? So less is more sometimes, right? The caller can always choose to do some extra processing. But if your job is to delete a node, do your job. And if there's more to be done, let the caller do it. Okay, unless you're told your delete function should print error messages or something like that. So if root's null, return null. Okay, so here's the guts of it. If root data is equal to data. So we want to delete the root of the current tree. So we need to find the largest node on the left. So we've got cases. So case 1, here's the root. We've got some stuff over here on the left. So this is a whole subtree, but over on the right. But on the left, we have null, nothing over there. Okay, in that case and that case alone, change the root to point to that stuff. That's how we delete the root, if there's no left subchild. So if root left is equal to null, set new root equal to root right, free the old root, and then return new root. Okay, so that's our easiest deletion case. Otherwise, we have something on the left. So we set temp equal to root left, and we know temp is not null. So now our picture looks something like this. This is root. There's some node over here, temp. And there's something over here. We're never going to deal with that. We don't do anything on the right side. Remember, if there's anything on the left, our algorithm is find the largest node in the left subtree and move that to the root. And do whatever else you have to do to make that happen. But our algorithm is always take the largest node from the left subtree, put it in the root. Okay? The only exception is if there is no left subtree. So if you're doing something with the right subtree being null, right, you're using a different algorithm. All right, so temp is root left, that's not equal to null. So if temp right is equal to null, that's another edge case. So that's the case where this is null, and we got some stuff over here. And in this case, the trick is to take the root, point it down here, and then have the new root adopt the old root's right child. So if temp right is null, set temp right equal to root's right, free the old root, and return temp, which is the new root. All right, so that's the second edge case. The third case is the general situation where we have a root, stuff over here on the right, a node here, some sort of stuff over here, and then a node, and then a node, and possibly more stuff here, and possibly some stuff over here, but this is going to be null. And the idea was this is the largest node, this is the previous node. So we're going to make largest the root, it's going to take this on the left, this on the right, and the previous node is going to adopt on its right the largest node's left child. All right, so general case. If temp right is null. Okay, otherwise temp has a right child. So I run a loop here where while temp right is not null. Okay, so temp is this thing. And we're in a case where we know temp right is not null. Because if temp right's null, we did that previous block of code. So temp must be pointing to something on its right, which means temp right is safe. It could be null, but it's not going to seg fault. So we're looking at the node that temp is pointing to. Okay, that's temp right is the node that temp's pointing to, and temp right is what that node's pointing to. And we want to get down to the point where temp is here. Temp right is the largest node, and temp right is null. So this will be temp right. And then temp right is null. So we loop while temp right is not null, temp equals temp right. That marches down the right side of the tree until we get to the point where temp's basically what we've been calling previous. So temp right is the rightmost child, temp is the previous node. So now we do the following. The new root's going to be temp right. That's the largest node. Temp right is going to be, so the previous node, right? Temp its right child is going to be the largest node's left child. So temp right is going to be temp right left. So that's going to do this adoption, right? So it adopts the largest node's left child. And then the new root's right child is the old root's right. The new root's left child is the old root's left. Free the root, return the new root. So that's the general case of deleting the root. If we're not deleting the root, then we have to use the recursive deletion. So if our data is smaller than the root, delete from the left subtree, and then set root's left to point to that new tree and return that root. Otherwise, we must be deleting from the right subtree. So delete from the root's right subtree, take the return value, set root right to that, and return the root. So that's deletion. All right, insert is pretty straightforward. If the root's null, create a new node and just return that. So you go from an empty tree to a tree with just a root. Otherwise, if the data is smaller than the root, insert into the left subtree, set root's left child, and return the root. Otherwise, we're inserting to the right subtree, so call insert on the right, set root right to the result, and return the root. So that's insertion. New node creates a new node, so malloc a struct node, set the data, make the left and right children null, and return the address of that node. And then traversal. So uppercase traverse basically calls lowercase traverse. And traverse takes the root of the tree and it takes this order variable. So it's 1, 2, or 3, left node, right, etc. And it basically just calls lowercase traverse and prints a new line, but it also sets this flag to 1 at the beginning of a new traversal. So new traverse tells me if I just started traversing. So lowercase traverse does the following. If the root's null, just return. Okay, nothing to print out. If we're doing pre-order, if we're doing node left, right, first thing we want to do is print out the root data. Okay, regardless, the next thing we do is traverse the left subtree in whatever order we're asked to traverse the entire tree, so the same order variable. After we've traversed the left subtree, if we're doing in order, then we go ahead and print the root data. And then we traverse the right subtree, and after the right, if we're doing post order, go ahead and print the root data. So that was just being lazy. Instead of writing 3 routines, I had 1 routine and you pass an argument saying which order. And it's really just a nod to the fact that you print either before, in between, or after the 2 traversals. Okay, but you can do this as 3 routines. But some people who did 3 routines, they copied and pasted, but they didn't paste everything they should have. And they ended up mixing like pre-order and post-order inside. That's the kind of thing I would do, so I tried to save myself. So PrintData is printing the value of root arrow data, but it does it paying attention to whether or not this is a new traversal. So if this is not the beginning of our traversal, it'll print a comma first, and then it'll print the data. And after it's printed a piece of data, it clears this traverse flag. So the first thing that you print with PrintData does not have a comma before it. Everything else does. So that makes the commas come out the way they're supposed to. All right, here's the examine routine. So examine just calls a bunch of other code. Traverse in 3 orders, do a breadth first traversal, print out the height, and based on whether or not it's balanced, print out either yes or no next to the word balanced. Search is classic recursion. If the root's null, it's not found, return null. If the root's bigger, if the root's equal to the data, return the root, in this case saying we found it. Otherwise, search either the left or right subtree and return the result of that. So that we've talked about. Here's my usage message. So if I want to give them more help, I can just put it in here and not have to tinker with my main program. Here's the freeing of the memory. So post-order traversal. So release is designed to release all the memory associated with a tree. So if I want to free the memory associated with the tree at root, first I release everything in the left subtree, then I release everything in the right subtree, and then I actually free the root. So it's a recursive algorithm. And if the root's null, I don't do anything. All right, and then breadth first search. So if the root's null, nothing to print, just exit out. Otherwise, this was all PA3 code. So init queue initializes a queue, returns a struct queue node pointer. So that creates a queue, and then I add the root to the queue. That's how we seed the whole algorithm. And then it's a 3-step loop. So remove the head of the queue, and if that comes back null, meaning the queue is empty, then I'm done. Okay. Otherwise, print out a comma as long as I didn't just remove the root. So that stops the first comma from appearing before the first number. Print out the data, and then if the left child's not null, add that to the queue. If the right child's not null, add that to the queue. Go back to the top of the while loop. So that loop does the breadth first traversal. And then when you're done, when the queue was empty, print out a new line and call my exit queue. That was the memory release function from PA3. And just goes through the linked list, clears out everything, and then frees the sentinel. Height is recursive. It's 1 plus the height of the left or right subtree, whichever is larger. So if the root's null, return -1, right? Definition, empty tree has a height of -1. This is one that Geeks for Geeks got wrong. They set it to 0. So empty tree has a height of -1. Tree with just a root has a height of 0. Okay, remember height is the number of edges from the root to the deepest tree. So one edge from here to here, this has a height of 1. If you just have a root, the only node is the root, and the distance from the root to the root is 0, right? So that has a height of 0. And if you have nothing in the tree, including not even a root, definition, height is -1, right? That's the only way to do the height of a null tree in order to make these other things work recursively. So if the root's null, return -1. Otherwise, find the height of the right and the left subtrees, add 1, and then this just returns whichever is larger, H1 or H2. So just using a ternary operator. Balance. So balance is not just making sure the left and right subtrees have the same height. Okay, we've always said balance requires 3 things. Left and right subtrees' height have to be close to each other, and the left subtree is balanced, and the right subtree is balanced. And you got to satisfy all 3 of those conditions. Otherwise, you have a problem with this. Where the left and right subtrees have exactly the same height, but this is definitely not balanced. right? It needs to be full on top before you start moving down too much. So if you just compare the height of the left and right subtrees, it'll say this is balanced, but it's not. So find the height of the left and the right. This was my absolute value function. And then if they differ by more than 1, it's not balanced. If the left subtree is not balanced, the whole tree is not balanced. If the right subtree is not balanced, the whole tree is not balanced. Otherwise, the tree is balanced. Go ahead and return 1. So that's a balance routine. And then the queue code, this was PA3. I got rid of the stack stuff and left the queue stuff and really just changed everywhere that I wanted an integer to take a node instead, a struct node star. And there's no changes to any of it other than the types of variables and return values. So init queue. Yeah, and I had to set my data to null instead of 42. But you don't really need to set it to anything. So data is a node, right? But I can still just say temp arrow data equals data. Right? It's no different from what we were doing. Data is a node. I set it equal to temp arrow data, and I return it. Right? So the code itself carries over directly from PA3. It's just the function declarations and the return values have to modify. All right, so any questions on that? So general comments, right? Put your name in your code. A few people didn't, so I took off points for that. Make sure you're doing what the assignment asks you to do. So for example, on traversal orders, I really wanted to see NLR colon, LNR colon, LRN colon, right? Some people didn't put anything out, they just printed out the nodes in different orders. No indication which was which order. Right, so I had to kind of guess and reverse engineer and take off a few points. Some people printed it out, you know, 1 number per line. Right, that's really unpleasant to try to grade because you're constantly scrolling backwards. So try to follow what it's doing. A few people needed me to type an I followed by a number to insert a number, right? And at first it just looks like your program's not doing anything. Because I insert numbers and I search and the tree's empty. And it's like, well, I guess nothing works. But go into the code and then it's like, oh, you need an I followed by a number to insert. And I'm not getting an error message with just a number, right? So I try to see what's going on and grade accordingly. But again, that's not something that other teachers will necessarily do. They may just run it through some automated system and whatever it gets as a grade, that's what you get. So try to pay close attention to the specifications. Memory leak, so 5 points if you had a memory leak. Lots of places to leak memory, right? When you're done with the tree, you gotta free everything. When you delete something from the tree, you've gotta free it. And you're using a queue to do a traversal, so you've gotta free all the stuff associated with the queue. So really easy to have memory leaks. A lot of assignments did not report memory leaks, but when I ran with Valgrind, in some cases I got hundreds of errors from Valgrind about uninitialized blocks, about doing things in the middle of blocks, about using blocks that had already been freed, and so on. If it didn't cause other problems, I didn't take off for that, but in most cases when I was seeing all these errors, there were other problems like deleting would cause a seg fault or something like that. So Valgrind will help you. Right? You want no memory leaks at the end, but if you're getting other things, warnings or especially errors along the way, go ahead and dig into those. And if you're not sure how or what they mean, come and talk to me. I'm happy to help you dig through those. So deletion. So sometimes you have a problem with delete. You try to delete a node and it just doesn't delete it. That doesn't usually happen, okay, unless your delete code, you just commented it out or something. But usually when there's a problem with delete, one of the following things happens. One, you get a seg fault. Okay, well that's a pretty obvious error. And it's actually a fairly benign one to try to debug because it's happening probably right away, right? Another possibility, you delete a node, but it actually ends up being replaced by a 0 or by some weird 8-digit number or something like that. And that might be something pointing somewhere different from where it's supposed to be. Another error is you delete a node, and the next time you traverse, you just get an endless stream of output. Right? Did that happen to anybody? Yeah. So that's easy to do, right? If you move a pointer in a tree and you inadvertently point to something above you, you create a cycle. And eventually, if your tree traversal is written correctly, it will stumble across that cycle, and it'll just start chasing its tail. And slowly, the stack will start filling up, and if you let it go long enough, eventually it'll seg fault. But did it? Okay, cool. Yeah, really easy to do, right? And if you see that kind of thing, you can go into the tree and start trying to trace the nodes, right? But as usual, try to find a really small use case that exhibits that behavior. And then you can either go in the debugger, figure out where the nodes are, where they're pointing to, and start making a map and see where the link is. And then you got to figure out how that got created. So find your code somewhere where you're pointing something to the wrong place. Another possibility is you delete a node and an entire chunk of the tree vanishes, right? And that's possibly not adopting the child of the node that you're moving or pointing something to the wrong spot, right? Or zeroing something out or freeing something that you shouldn't have freed. So all kinds of issues potentially with delete. And I'm not really worried about those, right? It's a finite time kind of question. Limited resources. If you work at it long enough, you're going to figure out what the problem is. But conceptually, right, if you've got your code mostly working, I think you're in good shape. So having said that, if you didn't get everything working correctly, you should probably come and talk to me, right? Either keep working on it yourself and or come and talk to me, and let's go through it and see what the issues were. Okay, just because you want to sleep well at night, and it's good just to sort of like make sure there's nothing conceptual going on. So what else? Height off by 1, that's not a big deal. Using the wrong definition of balance, that's not a big deal. Deletion, right, I insisted that you delete the way that the assignment says, which is take the largest node from the left and move it to the right. And a typical right, if you delete the 20 from this tree, what it should do is take the largest node on the left, which is the 12, and move that to the root. So it should give you this.
100 hours.
But if you decided to say, well, let's just see if the right tree is missing, and if it is, we'll just move the root, then you would turn this into this, right? And you get a totally different result. So other than the fact that it goes against what the assignment asks, yes, that's better. It's easier, and it seems to make things a little more balanced, right? And that's generally going to be the case. But the bad part is it's not what the assignment asked. So I took off a few points for that, not the full 10 for deletion, because you're successfully deleting, but a few points there. All right, so did I already mention that this is like the most difficult assignment from the class? Okay, so PA4 is definitely the hardest assignment in my opinion. It's definitely harder than PA5, and I think it's way harder than the stuff you've done before. It's also the slowest for me to grade because I have pages of test cases and looking at things one at a time, and more often than not going into your code and sort of studying how you implemented things. So it's a big assignment, and PA5 should be a little more relaxed. But when we do balancing trees in 223, we'll get back into some good tree stuff. So we'll have that to look forward to. That'll be in Java, yeah. And Java is a whole lot more fun to do this stuff than C. I mean, this is fun in its own way, in the same way that like building a sandcastle is fun, right? But kind of annoying at times. So Java will be a little different experience. All right, let's take a 5-minute break, and then I want to talk about a little more dynamic programming, and then we're going to start talking about sorting and different sort algorithms.